Good afternoon, everyone, and welcome back to my first ever A level lecture on YouTube. Now, today we're going to be going over chapter 4, graphs and transformations, and we're going to be looking at section 4.1 to 4.2. Now, as this is my first ever video, we're going to go through in depth everything. We are not going to leave a single thing behind. I'm going to make sure everyone's clear on every single little inch of maths before we step further anywhere else. So, the best way to progress with this is to have your pen and paper with you while you're watching my video, and make sure you're taking notes at every step of the way. I'm going to constantly be telling you to write things down and you can pause the video. I don't care if you put the video on 2 times speed, 3 times speed. It will be easier for you to understand however you like it. Okay, so let's start off with chapter 4, graphs and transformation. Now this chapter is all about different types of graphs. We have cubics, polynomials, linear, quadratics, quatrics, all those types of graphs, and how we can move them around and transform them. Today we're going to look at the very basics of the different type of graphs. Essentially, we have any type of graph is known as a polynomial graph, and the order of a polynomial graph is the highest power of that graph, as in of that equation. So let's assume we have ax squared. Let's say ax to the power of 3 plus bx squared plus cx plus d, for example. All of that is equal to y, or it's a function, let's assume. Okay, this is gonna be a graph. Now, the highest power, if we look at all the numbers, we have x to the power of 3, x to the power of 2, x to the power of 1, we can call it there, and no x, so x to the power of 0, essentially. Okay, the highest power in this situation, in this equation, is 3. This tells me that this is going to be a cubic graph. Okay, so this is what I mean by this point right here. The highest power of an equation is the order of that graph. Okay, so for example, let's say I have it in any other order. Let's say I got x plus 3x 34x cubed minus 25 or 45x to the power of 5 plus 3. It does not matter what order or the arrangement. It doesn't have to be the thing at the beginning. It can be anywhere within the equation, because if you move things around, it's still the same thing. So for example, this is the same as saying minus 45x to the power of 5 plus 34x to the power of 3 plus x plus 3. All I've done is arrange it in a way where the powers are descending order of x. The highest power in this situation is 5. That means the order of this graph is going to be the fifth power. Okay, so we're going to look at firstly understanding the types of graphs. So we have firstly a linear graph. A linear graph has the highest power of 1, which basically means it's x to the power 1, or simply x. If I have, for example, y equals to 2x, that is a linear graph. If I have y equals to x plus 3, that is a linear graph. These are straight line equations that you've learned in year 9. Okay, these are linear graphs. Second one you should all know this, is quadratics. Okay, the highest power of a quadratic is x to the power of 2. Now, what type of graphs are these? These are going to be y equals x squared, for example. That would be a u-shape. How do we know whether it's going to be a u-shape or an n-shape? Is we look at the power of the coefficient of x squared. Okay, the power of the sign on the coefficient of x squared is gonna tell us whether it's a negative quadratic or a positive quadratic. The name of this graph, there's a special name for it. It is called a parabola. Okay, these curves, the u and the n shapes, are known as parabolas. So when the number in front of x squared is positive, it's gonna be a u shape. When the number in front of x squared is negative, it's gonna be a n shape. Okay, so that's how we remember that one. The next one is a cubic graph. A cubic graph has, obviously, like a cube, x to the power of 3. This graph looks something like this, or it could look something like that, or it can even look something like this. Okay, so a cubic graph is one of these ones, and it has 3 different directions. So the way I like to remember it is the order of the graph is given by the number of directions the graph has. So what I mean, for a cubic graph, sorry, a quadratic graph first, let's look at this example. It's going up in this direction here. Up till that point, it's going upwards. and then over there it's going in a different direction. It's going downwards. That's why it has a power of 2. When it comes to a cubic graph, it's going up like this, then down, then up again. It's going up in this part of the graph, then it's going down in this part of the graph, and then it's going back up in this part of the graph. How many is that? That's 1, 2, and 3. So that's why the power is 3 on the cubic graphs. Okay, next we come to quadric. We come to the quadric graphs. Now, as you can tell by the pattern now, what type of graph this one would look like? It would be something with 4 different directions. So it might go up, and then down again. Or it might be the other way around where it go up, down, up again. Something like that. Okay, so this has 4 directions. It's going up, and it's going down here, and it's going down there. So essentially, that's 4 different directions. That's why it's a quadric graph. All right. Now what we can understand is the different types of graphs we have. You won't really be asked about the x to the power of 5 graphs, but judging by this pattern, you can understand that it's going to have 5 directions: up, down, and up again. That's going 1 direction, 2 direction, 3 directions, a 4th direction, and a 5th direction right there. Okay, so you can kind of get the pattern of these graphs. It's like that, and the power of 5, the order of 5 graphs, they're known as quintic graphs. All right, that is just a little Easter egg for you within this chapter. And if you like, you should copy all of this down in your notes right about now. Pause the video, and now we're gonna move forward. So the next thing now is understanding how these graphs form and how the directions are decided, whether it looks like the one I've drawn or whether it's a different one or whether it's something completely different. So let's first look at the quadratic ones. Okay, let's look at the quadratic ones. So understanding the quadratic graphs, we have a shape that's going like this and a shape that's going like this. This is going to be where y equals to x squared, and this one would be y equals to negative x squared, for example. Now obviously this one could be what, plus 1. Let's call this one plus 7, for example. Now how do we know that the directions are like so? We have to understand the very foundations of year 7 maths every single time, which is mid maths, right? If I make x a positive value, so when x is something positive, which means it's greater than 0, what would happen to my y? So as I'm increasing my values of x, as I'm going across the x-axis here, what is happening to my y? According to this, when I sub in any positive value of x, my y values are suddenly going to be positive also, whether they're positive or negative for x. So if x is positive, y is positive. If x is negative, y is still negative. That's why when we're going in the negative direction on the x-axis, when we're going into the minuses, the graph is still going in the upwards direction. The y values are still increasing. So that is why when x is positive, y is also positive. When x is negative, y is also still positive. Does that make sense? So now we understand why the U shapes are formed in that scenario. In this scenario, why is it always going downwards? If I make y, let's say my x value is positive again. If my x value, let's take a random number. Let's say x is 7. That means when I have negative x squared, that means I'm doing negative 7 squared, like so. I'm doing the power first, and then the minus is happening afterwards. So you have to remember indices and then the negatives come along, or the multiplication. So 7 is being squared and then the minus is on it afterwards. That means it's going to be negative 49. That means when x is, even if x is negative, even if x is positive, the y value is always going to be negative. It's always going to be negative. Okay, when my x value is a negative now, let's see what happens. If I make x a negative value, okay, let's say my x is going to be minus 3 now. That means I'm going to be doing minus 3 squared, and then there's another minus outside, which is from here. Okay, let me rub this out. Look at this. When I sub in minus 3, I'm subbing it into the x, and then that minus 3 is being squared over there. And then the minus is on it afterwards, like so. So when I square the negative 3, that's going to give me a positive 6, okay? However, because of the other minus that is still there, that is going to make it a negative 6. So whether or not my x is positive or negative, regardless of that, my y is constantly going to be a negative in this scenario. Hence, whether it's a negative number for x or whether it's a positive number for x, y is constantly going down. That is why it makes a N shape or a U shape depending on the sign in front of the x square. Okay, make sure you get notes of this down as I was saying that, and this is the key information here. This stuff in the box and this stuff in the box right there. Next, let's understand a cubic graph. Here I've got an example of a cubic graph. Now we're going to try and understand how these work. So essentially the basic look or the pattern of a cubic graph is something like this, where it goes like that or it goes like this. That's the basic foundations of a cubic graph. It's more roundy, which I haven't made it like that. So for example, it will be something like this or something like this. Okay, this is a positive example and this is a negative example. Now we're gonna dive deep into this cubic stuff. So essentially, let's say I got this example of a cubic graph here. Now we need to understand how these work. We're gonna first look at what type of roots they have or the main pattern. So the basic format of these is y equals ax cubed plus bx squared plus cx cubed cx plus d. Now a cannot be 0, okay, in this example. However, a b, c, and d can be 0. So a cannot be a 0 in this case, because if a is 0, that means the cube part is just completely gone. So everything apart from a could be possibly a 0. So your equation could but just be y equals x cubed, where the a is 1, for example. It could be a graph like that. Now let's have a look on Desmos what this actually looks like. So if I have y equal to x to the power of 3, as you can see here, it makes this type of wave function. Now this looks a bit different or a bit odd to the one I showed you a minute ago. The one I showed you had a pattern going like this. Now why is this called a cubic graph? I'll show you the difference in a second. This is called a cubic graph because it has the 3 patterns. So it's got the going up function here and another going up function here, but in between it's actually going downwards. That's the 3 phases of this graph: up, down, and up. Hence why the order of this curve is 3. Now, if it is a positive coefficient of a, so when a in this example is positive, the graph is going in the upward direction. When a is negative, the graph is going in a downward direction. Let me make that neater. It's going in a downward direction like so. Okay, I should have written it like this, where a is bigger than 0 or a is less than 0. Okay, it just cannot be 0 because then the x cubed would not be there. Now there are 3 or 2 main parts you need to know for this right now. You need to know that there are things called the roots of a cubic. What are roots? It's also part of quadratics as well. So what are roots? Roots are where the graph intersects the x-axis. So roots are where the graphs or curves intercept the x-axis. Okay, this is very important point. Now if we just look at the basics of a graph, we have the y-axis and we have an x-axis like so. So that's y, that's x. Now if a curve, let's say we're looking at a quadratic one first, the roots of this are going to be at these 2 points right here, this one and that one. Those are going to be roots. For example, this could be -2, that could be my +2. Okay, now why is that called a root, or why is it special to the x-axis? If you understand coordinates properly and how a graph works, along the x-axis the value of y is constantly 0. So let's say I have the equation y equals to, let's say 2x. Let's make it simple. Let's say I got x plus 2, x plus 1, and x plus 3. This is going to be a cubic equation. How do I know? Because when I expand this, the highest power I would possibly ever get is going to be x cubed something something something. So this would something be like this, x cubed da 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 da, whatever. Now this graph would obviously be going like this, something like that maybe. Yeah, it could be moving around or whatever. Let's say we move this around like this, for example. It could be somewhere there. Now the roots of this are special because those are the special points where this graph is cutting along the axis. For this example, it would actually be going completely in the negative. Let's change one of these to a negative number. Hold on. Let's make it like this. So this would be going like this, this, and that, for example. So my roots are going to be here, here, and here. Along this whole x-axis, y is 0. Y is equal to 0 all along the x-axis. All along this dotted line I'm making here, for example, that would all be where y is 1. All along this dotted line could be where y is equal to 2, for example. So essentially, these parallel horizontal lines are the y values. Now, when y is equal to 0, it's going to give us all the values where the graph is meeting the x-axis. So when I equate an equation like this, so when I make y 0, so I'm basically subbing in 0 into the y. So I'm saying that 0 is equal to all of that expansion, like so. So when I want to figure out my roots, I have to equate the equation to 0 or replace the y with 0 so that I know where my curve is going to cross at the x-axis, and that will give me the three solutions in this example. How do we know how to solve this? This is the exact same method as a quadratic, solving quadratics. When you have something equal to 0, three things are multiplying here. You have, for example, this part, this we can assume is a number, that's another number, and that's a number. If x is a number, there are a few different possibilities of what number it could be. Now, if these three numbers are multiplying with one another and it makes 0, that means either this one is 0, or maybe this one is 0, or maybe this one's 0, or all of them are 0. So we can actually say that maybe if one of these brackets, x plus 2 is 0, then we can equate that and we can say that, okay, we take away 2 on both sides and that will give me x is minus 2. What if I look at the second one, that's going to be x plus 1 equal to 0. When I solve that, that's going to give me x is negative 1. When I do the third one, that's going to be x minus 3 equal to 0. And that is going to give me x is equal to positive 3. There, I have just found my three roots. One of them is minus 2 over here. This one could be minus 2. This one could be minus 1. And this one is going to be 3. So this is how you find roots to any type of curve. You make y 0. Let's look at another example very, very quickly. Let's say I have, for example, the equation y equal to x minus 3, x minus 2, and x plus 3. This could be any type of curve. So when I expand this, it would give me some type of cubic equation. Let's expand it actually. Let me show you what a cubic equation would actually look like. It would expand these two first. That would be what? X squared minus 5x, and then we got plus 6. And that is going to multiply with the next bracket, which is x plus 3. Then I got x squared times x, which is x cubed. X squared times 3, which is plus 3x squared. Then I got minus 5x times that is going to be minus 5x squared. Then I got minus 5x times 3, which is minus 15x. Then I got minus 6 times x, which is plus 6x. Then I got 6 times 3, which is plus 18. When I simplify this, this is my like terms here, and this is my other like terms here. So that's going to be y equal to x cubed minus 2x squared minus what is that, 9x plus 18. Okay, this is a cubic. The highest power here is 3, hence the order of this thing is 3, order of this graph is 3, and this is going to be a cubic graph because that's the highest power. Now, if I was to find out what this looks like, or if I wanted the roots, if I wanted my roots for this equation, it would look something like this. Because it's got a positive coefficient for x cubed, this is going to be a graph going in the upwards direction. Let's just assume it looks something like, actually we'll draw it on later. Let's find the roots first. So to find the roots, y must be equal to 0. That means I'm going to equate the whole brackets to 0, like so. And then we're going to assume that each of these brackets equals to 0. So x minus 3 equals 0. So therefore x is going to be positive 3. That's one solution. X minus 2 equals to 0, and therefore x is going to be positive 2. That's the second solution. And then x plus 3 equals to 0. That means the third solution is going to be x is negative 3. Now I can pinpoint where these points are on my graph, on my grid. So I have a negative 3, so that could be minus 3. I have a positive 2, that could be 2. And then I have a positive 3, that could be there. So when I sketch this, because I know this was a positive graph or positive coefficient of x cubed, this is going to be going in the upwards overall trend. So it's going to be going something like this, this. Actually, let's make that cleaner. Let's make it go like that, that, and that. So that is what this cubic would look like, for example. Okay, all of that done by just finding the roots and the sign of the x cubed. Okay, there's another thing I gotta show you. I have to show you. It's called repeating or repeated roots. Okay, this is a very interesting one. Let's go back to a quadratic for this situation. Let's say I have something like x squared minus 4x plus 4. Okay, let's say this is my quadratic. When I factorize this, this will factorize to y equal to x minus 2 squared. This is a positive u shape because the coefficient of x squared is a plus. So, and the root of this is going to be where? It's going to be at positive 2, because if I factor this, x minus 2 and then x minus 2 equal to 0, therefore x is going to be equal to 2 or 2, obviously. So there's just one solution for this. That is called a repeated root. Even though this whole equation is a quadratic, it only has one solution. That means this is a repeated root. That means the graph will come to this point on the x-axis and bounce off right away from here. So the graph will come down like this and shoot off straight away at 2. Okay, it's not a graph where it's crossing it perfectly like this and you get two roots. This one is crossing it at exactly one point and bouncing off right from there. It's barely touching that point. So when I go to Desmos and I show you this one, x minus 2 whole squared, let's say we got, let's put in brackets x minus 2 whole squared, bang. You can see here, it's just exactly touching the 2 and then bouncing right away like so. Okay, now what can we do next? So this is a repeated root. Let's see what it would look like in a cubic scenario. A cubic scenario would have something like this, where it is y equal to x plus 1 squared into x minus 1. When I solve this, I know that either x, so when I make it 0, that means x plus 1 squared and then x minus 1. If I solve the left one, x plus 1 squared is going to equal 0. When I square root 0, square root both sides, okay, let's say the square root of 0 is going to be 0. Square root of that is going to be x plus 1. So this is going to be x plus 1 equal to 0. So therefore x is going to be negative 1. Okay, that's giving me one solution. From a quadratic equation, which is a square function, it's giving me one solution. That means I know this is going to have like a repeated root solution. So that's one of them. My second one is going to be x minus 1 equals to 0. And then when I solve that, that's going to be x is equal to 1, positive. Now when I draw this cubic, I know this is a cubic because this is going to have a maximum order of x to the power of 3. So this is going to be one of those up, down, up functions because the x square is going to be a positive. X value is positive here, x value is positive there. So this is going to be going upwards. Now one of my roots is negative 1 and my other root is positive 1. So what could the graph look like? It could be going, and where is the root? It's repeating at negative 1. That's the repeated one because that one was the one that's being squared. So my graph is going to start from the bottom left. It's going to go up and it's going to bounce off from here and then go through 1 exactly like so. This is how you would interpret a repeated root from a cubic equation. Alright, now what else could they possibly ask you? Let's look at an example question. Let's say here, in this example, the question is saying the graph of y equals x cubed plus bx squared plus cx plus d shown opposite right here on the right hand side are real constants. Find the values of b, c, and d. Write down the coordinates of the point where the curve crosses the y-axis. Okay, this is very interesting. Now, we can clearly tell that this is a cubic graph where it's going to be in the form of something x plus y, x plus something into x plus another thing into x plus another thing, or it could be minus as well. So we know this whole expansion will come to this equation in the question. Let me highlight this so it's clear as well. So what we can say, looking at the graph, it's crossing at -3, -2, and 1. Those are the three roots, okay? So what can I say here? What can I do? I can basically do this. I can say that, okay, because it's going from -3, we knew before that the sign is always going to be opposite to the root. So the first thing should be x plus 3, because when I solve this to be 0, I know that it's going to be x equals to -3. So hence, I'm going to put the opposite sign in. The second one is going to be x plus 2, and the third one is going to be x minus 1. Because when I solve it for 0, x plus 3 equals to 0 is going to solve to -3. When I do this, x plus 2 equals 0 is going to solve to x equals -2. When I solve x minus 1 equals 0, it's going to solve to x equals +1, which are the three roots in the question. Secondly, we figured out this. Now we can expand this out. Let's expand all of this out. So when I expand this whole thing, this is going to be what? X times, so I'm going to do x times x, which is x squared, x times 2, which is x 2x, and then 3 times x, which is 3x, and then 3 times 2, which is +6. All of this is going to multiply with the second bracket now, which is x minus 1, still equal to y. When I expand this, x squared times x is going to be x cubed, x squared times minus 1 is minus x squared, 2x times x is going to be plus 2x squared, and then 2x times minus 1 is going to be minus 2x, plus 3x times x is going to be plus 3x squared, and then plus 3 times minus 1 is going to be minus 3x, plus 6 times that is going to be yeah, all of that. Now we got this. Simplifying it all down. Hang on a minute. Did I mess something up? Nah, should be alright. So that doesn't have a like term. So we know this square, and this square are like terms. I know this is this, and this is a like term as well. So simplifying it down, y equals x cubed minus x plus 2 is going to be plus 1, plus 3 is going to be plus 4x squared, minus 2x minus 3x plus 6 is going to be minus 5x, add 6, which is going to be plus 1x, and then ends with a minus 6. Write down the coordinates of the point where the curve crosses the y-axis. Now, I done this assuming that it wasn't in the question. What does my equation end with? If I make x equals to 0, okay, understand this. Along the y-axis, the value of x is constantly 0. Every coordinate on this y-axis starts with 0 something. Now the graph is crossing right there, which is at -6. So when I make my x equals to 0 in all of this equation, I'm saying that, okay, y is equal to, hang on, where's my pen not working? I'm saying that y is equal to 0 cubed plus 4 into 0 squared plus 0 take away 6. Now all my x's are 0, and I solve all of this. This is going to give me 0, 0, 0. So y is equal to -6 when x is 0. That means my y-intercept is going to be -6. So for the answer for part A, we need to find the values of b, c, and d, which are going to be from the equation we found right over here. So the value of b is the one next to the second x squared term. So that b value is going to be 4. The c value is the next one over here, which is going to be 1. And the d value is obviously going to be -6. And for part B, where they ask for the intercept of y-axis, that would be equal to -6, same as the d value. So this is what you would write in for the answer. Hope you liked the video, guys. I'm going to do a second part to this, carrying on with this type and going on to quadratic equations. So make sure you leave a like and comment for more content like this, and make sure you subscribe.